Harisankar PS has been building software as a service applications and APIs using Ruby on Rails framework and Postgres databases for the last Postgres SQL databases for the last 6 years. He is a free thinker and believes that there is more that mankind could achieve in this century. Presently serving as CEO of Red Panthers, he has made sure that Red Panthers keeps the bar, raising each quarter and hit the target. Red Panthers is a specialized Ruby consultancy based out of Kochi, Kerala. He is an active organizer of events around open source. Harisankar.
Okay, good afternoon, everyone. Before we start, I want to take a group fee, which is a group selfie. I do that at all conferences, not just you. So please bear with me for a second. Thank you. So I'm going to talk about something that we all hate, which is failure. I'm sure that there is not a single person in this room who has had his app work exactly the way he intended from day one. Because if you are, then you're lying. Okay, and so I co-founded this company called Red Panthers in Kochi 3 years ago. We work in Ruby on Rails. The company was founded because I wanted to work in Ruby, and there was not much company that did that in my city. And we like to think of ourselves as a community-oriented company because we do a lot of sponsoring, organizing. We sponsor students for conference, etc. My name is Harisankar. For those it's hard to pronounce, you can call me Haris. I'm known as CoderHS all around the web. So Twitter, Facebook, everywhere it's CoderHS. I organize the Kerala Ruby meetups. Since 2012, I organize Rails Girls Kochi and Open Source Saturday. I've been a local organizer for RubyConf India in 2016 and 17. I'm a Ruby programmer, an Elixir programmer, and a Crystal developer who has an application in production. So there are actually crazy people who do that, as I've been told yesterday. I'm from a city called Kochi. It's way down south of India. The state is called Kerala. I have an interesting fact about India. Well, India has 22 official languages, 1,653 spoken languages, and 50,000 dialects. And I know 3 of them. So you shouldn't feel amazed if you find 2 Indians talking in English rather than any other languages, because I have no idea. And I'm loving the Philippines so far. It's my first time here. The food is great, the climate is same as back home, the people are good, the Ruby community is great, the beer is nice, and the food is wonderful. I had my first fried octopus yesterday, and it was delicious. Thank you, Engine Yard, for the dinner. And it seems, I just got this today, that my blog is getting the 3rd highest traffic from Philippines, which is great. So let me start. So I'll start with a question. And I was asked this question by my cousin, Vishnu. He right now works in Google. He asked me when I was in school, the question was, which is better, hardware or software? And we're all programmers here. So if it's a firewall, imagine that we are talking about firewall, hardware or software. Well, in school, me being a student, I said, of course softwares are better because I can program stuff, put more filter, more control, and that's great, right? So I said software, definitely software. And he gave me an example that says, let's imagine that someone is hacking your system, and you're going to use software to filter it, prevent IPs, and everything. And the hardware guy is just going to cut the cable. There's no way anyone can steal your data if there is no internet. And this is what I felt. But Ruby is an object-oriented programming language. So that's the takeaway from this conversation. Everything that we do in software is replicating a real-world entity. Something that's actually explained in real world can be done in software. And there's no better language for this than Ruby. And keeping that in mind, I'm going to talk about circuit breakers. So circuit breaker pattern, it's not something new. It's been there for a long time. If you go to the enterprise Java world from the 1990s and even before that, people used to talk about this. And it's kind of simple. So how the circuit breakers work at your home, in which during an electric surge, it prevents your house from burning down. And it saves life, and it's mandatory in every single person's house. So the circuit breakers in software, it's kind of the same. You wrap your code around another piece of code, which monitor the success rate of your code, and it breaks the circuit if the code is breaking too often. And the mantra here is fail fast. Fail you will, fail fast, so you should. So it's basically about being bold at the time of failure. So imagine that you have a database and you're running a query and all of a sudden your database just crashes. Your app shouldn't crash. Ideally, it shouldn't crash because we still have users in it. Imagine that you're using a third-party API service. Even then it shouldn't crash. And we can't build a software being 100%. But the sad thing is we as programmers assume everything to go in the right way. But the truth is it seldom does. So I'm going to give an example of how a circuit breaker is going to be used. And this is my example. It's a Google rank tool. Just an introduction. So this website called XYZ lets you store the Google ranks, not the Google ranks, the keywords of your websites, so that every day at midnight it goes and checks how much the rank has improved. So imagine Red Panthers being #1 for Ruby on Rails in India, and every day we go and monitor, are we still #1? So that we can create a graph. And we'll know when it goes down or when someone else comes up. So this is how the system works. So we have a Rails application, and every day at midnight, because we're not building just for Red Panthers, we don't have 10,000 customers in this. And we have like 100,000 keywords and websites. So how we do it is that we send requests to a third-party application asking us what are the ranks of all these keywords. Now I'm sure that many of you can relate to this, because if you're using a third-party website, this is how you communicate. Sometimes synchronous, sometimes asynchronous. You send a request, you expect it to reply. In this case, we get a response sometime later because we are sending them too much jobs. But we're sending it one by one. Now imagine that all of a sudden the server is feeling sick. It could be anything. There's a programmer at the other side. He has a family as well. He has his own problems, and the site wasn't as responsive as we thought. And one day, when we started sending like 2-3 requests, it's hitting with failures. But our system just sent again 100,000 requests to it, imagining that it would go well. Now we created a problem for 2 people here. That is, our application just got a huge load of 500s, which is creating a problem for our logs. Our roll bar is off the roof, and our system is not going to update itself in that day because we haven't got the rank. On the other side, the server, which is already slow, just got 100,000 more requests. And it's literally have no idea. And you're not going to get anything back. And you get the worst thing imaginable, that you get called at 3 a.m. in the morning, people from across the world complaining that the site is down. Now this is something that we all need to think about, because when we say production ready, what I like to say is that I should no longer get calls at midnight. That's what I call production ready, not just because some users are using it. Now, this is a case for systems that uses third-party APIs. Now, imagine that you have your application is so big that you decide to split everything up as microservices. You have 10, 20 different microservices. And all of a sudden, one of your own microservice just decides to slow down by 200 milliseconds, which means the entire pipeline just got slowed. And once by 200 seconds, the other one by 400 seconds, altogether it became 1,000 to 5,000 seconds, which is what we call a snowball effect. It started as a snowball, it's ended as an avalanche, which is not something great. It's something that we can't actually accept. But I'm going to take a small detour here. Now the next question is, what is a failure? Now, getting results that you do not expect, that's a failure. Giving a different result other than the one expected is a failure for some people, and some people call it feature in disguise. But let's say it's failure. And the third thing is something that developers kind of overlook, is that not getting the response in a given time. In many cases, with the system works, it's just that it takes 1 hour to give me the result. That's it, the system works. But we can't run a business in which you have to wait for an hour. There are issues. So this should be something that should be taught as basic to every single programmer there is. Timeouts. Right? You have a time to do something. That's it. We need checks and balances all throughout the application. Especially if you're talking to the database or if you're writing a query. That's a really good performance tip for you. Because your app can't be slow if it doesn't run. You can't have a slow-moving query if it doesn't run more than 10 seconds. Simplest performance tip you can imagine. Now, we don't think about performance unless we do microservices, because then we're asking another developer to build something for us. And we create something called an SLA and says that, okay, I need this response in 200 milliseconds. That's it. That's the SLA. But we need to think it all throughout. And if you think of an HTTP request, Ruby waits for 2 seconds by default. 2 seconds by default is literally having the customer say, bye-bye, I'm going away. So that's something that we can't accept. So we need to build system, we need to take care of it. And timeouts help us isolate faults. Because we will know exactly where we are slowing down, because all throughout the application, we made sure the system doesn't slow down. And if we're breaking at one particular point, we can find it. It forces us to use the resources properly. So I manage a team, and we always hear this excuse that says, oh, we're just doing it right now, we will optimize it later. Okay, we will make it working and optimize it later. It never works. It never happens. I've never seen a project that's successfully done that. So we have to put all the checks and balances from day one. You have to say, okay, this thing has to run in this time, or it shouldn't run. And timeouts is mandatory if your motto is fail fast. Because we need to fail fast to build a scalable product. Because we shouldn't be failing in production, we should be failing everywhere. And we shouldn't be fear failing, we should be accepting it. Because this failure is not me failing as a programmer, it's just me failing in this use case. I can still fix it. So coming back to circuit breakers. Now, I'm saying all this agnostic. You can do this in Java, Ruby, anywhere. Crystal, Elixir. Anyway, basically this is a design pattern. And talking about patterns, it's when expert programmers see that we are actually reusing our solution over and over again, it ends up becoming a pattern. And the most popular pattern for us is MVC, Model View Controller. But there are more patterns out there in the world. So definitely reading up on it will help you improve and handle a lot of cases. So a circuit breaker has 3 states. Well, the circuit breaker at home has 2 states. It's closed and it's open. A closed state is when you get all the current through. So I have this API request from my application a couple of steps back, and all the requests are going through, the world is happy, and everything is good. And all of a sudden, I find out that a particular request of mine just failed. One failed, that's fine. Then the second request failed. Then the third request failed. And the fourth request failed. Now, if we had the circuit closed, it means that we are going to continue sending maybe a million requests more to this unresponsive service just to find out that it's going to fail. So that's when the circuit opens, in which we will start saying to the circuit that it's open right now, so you're no longer going to send any more requests. By default, it will fail. And now we just fail faster. Rather than waiting for 1-2 seconds or maybe 1 whole minute to find out that we are not getting a response back, immediately we just said that we failed. And now this is good, because now we know that it's going to fail. Now we can go for the backup. We can go for another service. We can load stuff from the cache. Or we can just politely say, our system is unresponsive right now, please try again later. Which is all much better than actually having to find out after waiting for a long time. And we should never test the client's patience. And the third step, or the third state, is the half-open state, which is different from the circuit breakers at home, in which our system will try to heal itself. So let's say that you have decided that after some time, maybe like 10 minutes, let's send one request through. Okay, let's see if the service is back. And you just send a request, it didn't come back, failed. Okay, we'll wait another 10 minutes. Now it went through. Oh, that's good. I'll wait another 5 minutes. Okay, one went through. Okay, let's send another one more. And that too went through, which means the service is back up now. Then let's start sending all the data again. Then the system just turned itself back on. So that's something different with software. And if I told my customer right now, here software is much better than hardware, because we have a third state. So summarizing all those points, like this is when the system, like all the open states, when we get everything through, no failures are happening, everyone's happy. Open state is we have crossed the limit. Now, a particular point about here is that the limit factor here depends on business. Like when a company like Heroku or Netflix implemented this, they went for percentage. They said that failure is going to happen for sure. So what they did is, if 1% of the request is failure, then open it. Anything less than 1% is not accepted. But for us, 5 requests failing, that's a big no-no. We need to break. So that's where all the custom logic comes in with respect to your business. If you're into payments and one payment fail, oh yes, that's hell. We can't lose money, so we need to look after it. So there's other cases. And you need to also handle these exceptions based on your business as well. Like for example, in my case, in which we are sending Google ranks, we just copied the data from the previous day. Okay, we just kind of tricked the users to believing that the rank didn't change, which is fine, right? Because Google is not going to make someone who's number 1 20 overnight, hopefully, unless Google goes crazy. And definitely they do have developers like us, so they might go crazy, which is fine. But if in the case of payments, you can't say success without actually getting the money, in which you say, okay, we have the second payment gateway, let's go there. Or, please try again after some time. Or just we can say, I'll retry after 10 minutes, which is also fine. And in some cases, it might be just showing the data, which is the new data hasn't come in, but we have the cache data. So we just show the cache data. It all depends on the use cases. And half-open state, now here's where we can be even smarter, in which we can actually do some self-healing as well. As we're waiting for the service to come online, we can actually try restarting the service if the service belongs to us. We can try checking the logs. We can ping the service and see, are you online or are you dead? All this thing can be done in a half-open state, which is something specific to your business as well. Another really good thing that came out of this, using this pattern for us, is that we could say to our non-technical users, I mean members of my own team who are non-technical, something more quantifiable. Because before, what we used to say is that this API vendor of ours is slow by 3,000 milliseconds, and I have people staring at me saying, and calculating in their head how much is a millisecond so that they can convert it. And instead of that, we started giving them numbers saying that this API vendor is not good because we are having 20 failures per minute, which is high. We can say that this vendor is bad because at 12 a.m. at one particular point of time, the failure rate is high compared to when at midnight. So we get all this quantifiable analytics using the circuit breakers because we are tracking when the breaker is on and off, because we can build a logging system for that. Another way is that we could measure the performance improvement of a code. So this is something that we did personally, is that if you have multiple servers that have the same code, you can push to the new server, or one of those servers, the new code, and monitor the failure rate. If the failure rate is same as what it was before, keep it, it's fine. If it's less, perfect, mass deploy. If it's bad, roll back. Roll back as fast as you can. Do not keep it. So you can automate all this without human intervention because even the system has this number right now. Instead of asking the system to measure the millisecond increase or decrease, we just ask them to check how many times the circuit breaker is stripping. If it's stripping too often, the code is not right, roll back, send a mail to developers. If it's good, mass deploy. Your DevOps is taken care of. And you can be happy, the project manager can be happy, and everyone's happy. Yay. Another thing we use circuit breakers for is improving performance. So our circuit breakers that we use have timeouts as well, which means, so take the service, it's 80 milliseconds, 100 milliseconds, 150 milliseconds, and 75 milliseconds. Of course, all of them are hypothetical values. Please don't misunderstand me. So all of a sudden we decided, let's make one of our service faster. Let's make it 125 milliseconds. So we can easily change the value of that circuit breaker to break anything higher than 125 milliseconds, and we start optimizing it. Now the good thing here is it's all on production. All this data comes from production, and we can easily measure it. If the break is the same, we did good. We increased, we started sending it more information, more data, it's responding faster, the code is good. Instead of us hypothesizing that this is the speed, this is the error rate, all this thing, we can literally say, dude, it's breaking less right now than it was before. That's it. So how do we implement it in Ruby? My personal opinion is build your own. And it's kind of easy because this is a pattern, and I just did this at the back of the hall in 10 minutes, this code. So this is not my production code, and I'm not breaking any NDAs doing this. So it's basically a class wrapping another code. And we're just incrementing a counter. So in this particular circuit breaker, we are incrementing it 5 times before it breaks. It's good, right? I can wait 5 failures. And if one of the requests goes through, it resets it. It resets it to 0. And it is good. So we need to give it a threshold time here. That's what I'm saying, because one of the requests could fail due to a latency issue or network issue. That shouldn't trip off the circuit breaker. Then we'll be having false alarm across the board. So you need to have that threshold in your mind. In some cases it's percentage, some cases it's numbers. In some cases it's time. Because we had a situation in which it breaks more during peak hours, peak business hours, and it's sleeping like a baby at midnight. So always, you can incorporate that code here. Or if you want to use someone else, there is this particular gem. It has a DSL that makes your life easier. This is something that's used by Heroku, so it's battle trusted there. This gem is based on what Netflix did, though Netflix did in Java. So this is the same architecture, the design used there. To summarize, seeing this really fast is better than seeing this after 1 minute. Thank you. I think we have good time for questions.
Yeah, you have time for questions.
Any questions? Yes. The crystal developer.
Here.
Yeah. I have a question. Actually, it's something confusing me a bit with the circuit breaker things, which I like. Is what's happening if, let's say, the service is breaking based on some argument, some variable only. Let's say the service is breaking 1/10 request only, but always when the user is searching for something specific or something like that. It means like all your website, all your service going to break. You are going to open the circuit. So that means the 90% of your customers are going also to see this page like we are working hard to fix these things. I mean, what is your thought about this case?
Right, so that's a good question. Just rephrasing that, assuming that it's the argument that's creating the problem and the service is fine. So there's two things that we did that I guess I could explain here. Is that one, so when we're capturing the exceptions, we look into the type of error that was created. If it's an argument error, but it's an API service. So basically, this data goes to the API service, right? So the argument error has to come from the API service. So actually the circuit passed. So which is fine, no error was made. But if some kind of a data, let's say false encoding was passed in by the user that breaks the system, then we look at the type of errors. And also, based on the number of users and the type of request, we set the threshold. Like in the custom one that I made right now, I need to get 5 concurrent breaks, right? One after the other. Okay, it can't set off just because one failed. In your case, maybe it's a percentage. Okay, or we can ignore if it's the same user who's getting the problem. Because it's as you said, it's easier to apologize to one user rather than to 100 users, right? Which makes sense, but that's where we have to tune the circuit breakers. Okay, and it depends on how mature your code is to prevent the false alarms. Any other questions?
Thank you.